We'll be reading Chapter 12, Section 1, The Causes of Weather. Have you ever sat back and watched the sky on a lazy summer afternoon? You might have noticed clouds of different shapes, or felt the warmth of the sun against your face, or an occasional puff of wind as it cooled your skin. All of these phenomena are part of a highly organized sequence of events with specific causes. Those events and the factors that cause them are all part of meteorology. Meteorology is the study of atmospheric phenomena. The root of the word meteorology, meteor, is a name given in modern times to a flaming rock falling through space. But the ancient Greek meaning of meteor was high in the air, and it is the meaning that pertains to meteorology. Clouds, raindrops, snowflakes, fog, dust, and rainbows are all types of atmospheric meteors. The primary types are clouds, droplets, and forms of precipitation that contain water in any phase. They are known as hydrometers. Smoke, haze, dust, and other condensation nuclei are called lithometers. Thunder and lightning are examples of electrometers, which are visible or audible manifestations of atmospheric electricity. These various phenomena are the objects and events that meteorologists study. Weather and climate. Atmospheric phenomena shown in Figure 12.4 interact to affect the environment and life on Earth. This is basically what we call weather. Weather is the current state of the atmosphere. When we speak of weather, we are referring mainly to short-term variations in the atmosphere. These variations can take place over minutes, hours, days, weeks, or months. Long-term variations in weather for a particular area make up climate of that area. Climate is usually averaged over the course of 30 years or more. You'll learn more about climate in Chapter 14. For now, simply recognize that meteorology, weather, and climate are related. Meteorology is the study of the atmosphere. Weather is the current state of the atmosphere, including short-term variations that affect our lives, and climate describes the average weather over a long period of time. A question of balance. As you've learned, the sun heats the Earth's surface. The Earth radiates back to space about as much energy as it receives over the course of a year. In meteorology, a crucial question is how that radiation is distributed around the planet. You know that the sun feels hotter during the afternoon, when its rays strike Earth more directly than it does in the early morning or evening, when its rays strike Earth at a low angle. The sun's rays are more spread out when the Earth strikes at a low angle, as you'll see in the mini lab later in this chapter. The same amount of energy is spread over a larger area. As shown in Figure 12.2, the solar radiation reaching Earth's surface at the poles is therefore less intense. This explains in part why the tropics are warmer than the poles. But why don't the tropics become steadily warmer if the sun is always directly overhead? How do regions manage to maintain fairly constant average temperatures? Balancing the budget. The tropics and other places maintain fairly constant average temperatures because heat energy is redistributed around the world. The continual motion of air and water reallocates heat energy among Earth's surfaces, oceans, and atmospheres, and brings it into balance. Virtually everything that we consider to be weather, every atmospheric motion from the tiniest convection current to thunderstorms to large-scale weather systems, is part of this constant redistribution of Earth's heat energy. Air masses. In Chapter 11, you learn that when air over a warm surface, such as a parking lot, becomes warmer, then the surrounding air becomes of conduction. The warmth air rises. Conduction. The warm air rises. Now imagine the same process taking place over thousands of square kilometers. Imagine that the air remains over the same area for days or weeks. The result is the formation of air mass. An air mass is a large body of air that takes on the characteristics of the area over which it forms. Meteorologists call the region over which an air mass forms the source region. Air masses form over land or water. Those that form over land have less exposure to large amounts of moisture, so they are drier than those that form over water. Air masses take on the temperatures of the source region too. Classifying air masses. Air masses are classified exactly as we have already described them, according to their source regions. The main type of air masses shown in Figure 12.3 are warm and dry continental tropic, CT, warm and humid maritime tropic, MT, and cold and dry continental polar, CP, cold and humid maritime polar, MP, and Arctic. An Arctic air mass is basically the same as a continental polar air mass, but much colder. It's the type you've heard most about because it brings the most frigid outbreaks of winter. Extremely cold Arctic masses are usually associated with high pressure as a result of the massive sinking of cold air over a large area. Source region. All 5 main types of air masses can be found in North America because of its continental proximity to the source regions associated with each air mass. Maritime polar air forms over the cold waters of the North Atlantic and North Pacific. It primarily affects the west coast, bringing occasionally heavy rains in winter. Continental polar air forms over the interior of Canada and Alaska and can be quite frigid in the winter. When nights are long in the summer, however, CP air can bring pleasant relief from the heat and humidity because of its cool and relative dry composition. The origins of maritime tropical air are tropical and subtropical oceans, such as the Caribbean Sea and the Gulf of Mexico. In the summer, MT air brings hot, oppressive, humid weather to the eastern 2/3 of the United States and Canada. The desert, Southwest, and Mexico are the source regions of continental tropical air, which is hot and dry, especially in the summer. Arctic air develops over latitudes above 60 degrees N in the ice and snow covered regions of Siberia and Arctic Basin. During the winter, this area receives almost no solar radiation, but continues to radiate heat out to space, so it can get very cold indeed. In addition to temperature and humidity, another important characteristic of an air mass is its stability. The stability of air is an important factor in its ability to produce clouds and precipitation. Air mass modification. Like the warm air over a large city during a summer afternoon, air masses do not stay in one place indefinitely. Eventually, they move, transferring heat from one area to another, and thus establishing the heat balance discussed earlier. As an air mass moves, it may travel over land or water that has different characteristics from those of its source region. The air mass then starts to acquire some of the characteristics of the new surface beneath it. When this happens, it is said to undergo air mass modification, which is the exchange of heat or moisture with the surface over which the air mass travels. Table 12.1 summarizes the characteristics of the main types of air masses before modification. All air masses become modified at some extent as they move away from their source regions. Eventually, an air mass becomes modified to such a degree that its characteristics are almost the same as the new surface over which it is traveling. At this point, the air mass has lost its original identity and is now simply put part of the air over the new source region it has encountered.